Yeah, there's a lot of ideas in this section, and we're going to spend a lot of time in class on it, about 2 days. I'm just going to make a brief video to try to go through each idea once, since there's so many. One of the things that we have, for example, in this section is, what do we do when we have a log and it's not something that we can put in our calculator, and it's not something we can solve? If I try to change this over and label this log A, B equals C, and I write I, C, a B to try to change this over, it's not very helpful because my A is 0.3, my exponent's the missing part because it's a logarithm. I don't know what power to raise 0.32 to get 58. And one thing we saw in yesterday's lesson is what we could do if we wanted to is I could call this x and I could log both sides and I could solve it that way. So I could actually do this without a change of base formula if I log base 10 both sides. But there is a formula though we could use, and it's another way to do this. And what it says is if I've got a log like this, and it's a base, my base in this log is 0.3, what I can do is I can change it over to a log base 10. I can say, well, if I want to, I can make this, I can change this into log base 10. So what I'm going to do is I'm going to take log base 10 of the 58, the number that normally would be my B in a log ABC. This is the number I'm circling in black. I think of it as a log of the number that's written largely. And I'm going to make it a log base 10. I can change it to any log I want to. So we either change it to base 10 because it's in our calculator, or our calculator also has a base E that's ln. So you could also use ln instead of log base 10. But most people prefer log base 10. I know I do. So if I want to change it over, I say I'm going to make it base 10, log base 10 of the 58 over log base 10 of the 0.3. And then I can just stick it in my calculator and find the number. And if I type this in, I just really type in log 58, close that parentheses, and then divide by log 0.3, and I end up with negative 3.3725. We'll go out 4 digits always on things just because it's a kind of a nice just thing to do. It keeps our number pretty accurate. So I can solve this, and again, this is called the change of base formula, where I can take any log of any base they give me, and I can actually use my calculator to solve it if there's a numbers in it, just by changing it with this formula right here. So here's the formula that we use, and the A over here, if you look in the formula that I used, that's when I changed it to log base 10. So if you want to just think of it as log base 10, you could be log x, because that's log base 10, over log B. And remember, B is always your base, which is what I had circled in red here. In this section, we get into evaluating some other logs too. If you look, let's look at a couple of problems. Like for instance, 13 says log 49 of 49 is 8. We've done some of these in class together, and what we noticed is if I label this log ABC, and I don't know what the answer is, let's say, and this is my C, and I change it over to I, C, and B, there's something interesting that happens. My A is 49. My C is my missing part, or I could put X there if I wanted to. I'm just putting a question mark for now. And then my B is 49 to the 8th power. Now you look at this, if these two expressions are equal, that must mean the missing exponent must be 8 over here, my X that's missing, or which, I could have put that here. I could have called question mark X, and I could have written X here. Well, what is it? X is 8. So if you look back at the pattern that's going on here, when you have a base, and then you have over here on your B, you have that same base raised to some powers. This is not mathematically correct. A math professor would have a fit with this. But it's almost like these two things are canceling each other out because they're what we call inverses. They undo each other. And my answer is just 8. I could look at that and see that one pretty easily. So if you ever see the same two numbers as your base, and then up here you've got a number written with a base, these two things are undoing each other. You could just write that number down. So there's a lot of problems like that in this section. 3 log 24 to the negative 2/3. Okay. Now, one thing I can do, I might want to use my log properties here. This one is a little complicated at first. Well, I could do, there's a couple of things I could do here. I'm just going to choose a way and go with it because I could say, okay, there's a 3, and it's multiplied by this whole log 24 negative 2/3. And this is like the previous problem, if I can just separate it out that way. It's like these two things, they're inverses, they undo each other. So what I end up with here is 3 times negative 2/3, which actually is just equal to negative 2. Oh, sorry. Since I didn't notice this thing was going, I thought I cut it off. I'm going to go back and do number 17, just since there's time. It's 3 log 3 of 7. Okay, so if you can't read the book, that 3 is meant to be a little log there. Now let's think about this. This is equal to something, right? We don't know the answer. This is I, C, a B. If I want to rewrite this as a log, it might make it a little easier for me to understand what's going on here. It's log base 3. My B is I don't know. Okay, so this is usually the number I write here is 3 to some power is equal to that question mark. Could put an X there. And then the C part is log 3, 7. So do you see the answer now? Remember, I could have put an X here, and I'll do it now. Oh, if I've got log 3 of some number of X is equal to log 3 of 7, then it must be that X is equal to 7. So you can rewrite it and see it if you don't, if you kind of look at this and it looks a little strange, just label it like we've done everything else and you can figure it out. The thing about it is, do you see now that what's happened with this is this base 3, a base of an exponential term, and this log 3 is like they cancel each other out because they're inverses, and we get the answer 7. So if you look at 18, for instance, we could do that one really quickly now because we got 6 log 6 of 13. These two things are like inverses of each other, and we get 13 as our answer.